Okay, hi guys, MySQL 101 Security Basics. I apologize in advance for anyone that thought I was going to read from a textbook. That's what the MySQL documentation is for. That's not what I'm going to do. I have approximately 20 minutes to change your mind on security and make you realize why you've got to do it. So the best way to do that is with a little entertainment. So let's get on. So first of all, I'm an information security architect at Percona. I've been with Percona since January 2013. In that time, I've been a remote DBA and all the boring stuff. I got to be the EME lead and then the security lead, and then Percona said, hey, do you want to do this full time? Yeah, of course I do. So I've got several talks on security. Slides will be made available. Another apologies, my laptop decided it didn't want to do double display, so now some of the formatting is thoroughly boned. So let's talk about the Kübler-Ross Model. Now, the Kübler-Ross Model is the 5 stages of acceptance of grief, which I'm going to have to go to my phone now because I can't see my notes. These are denial, anger, bargaining, depression, and then finally acceptance. So once you accept that you're going to be compromised at some point during your career, you can start to focus on what you can do about it. Not worrying about all the poor people that are going to come across and try to own your solution. Just pretend you already have been, because chances are you have. So we need to then get into damage limitation. You need to isolate the parts of your solution that's going to cause you problems and then worry about the mitigation on there. You have to focus on what can be controlled. And like I said about the slides that corrupted for the second time on my trip over, this is supposed to be an animated image. So let's not talk about 3-letter agencies. We're not going to talk about the TSA, who decided they were going to pat me down 3 times and search my bag twice. We're not going to talk about the NSA, who are probably listening to this talk right now. Hi, guys. We're not going to talk about your government, which taps everything and funds the NSA in the first place. We're not going to talk about espionage or the doomsday scenarios, you know, because when the world ends, we don't care about the data, because we're all going to be dead. So let's talk about a solid foundation. And it's not really a rib on the poor so-and-so that's lost their house here. It's more to borrow from the parable. It was a foolish man that built his house on the sand. Okay? You have to worry about what you're building your stuff on before you even put MySQL anywhere near it. Is it a virtual machine or is it bare metal? Doesn't really matter. If the underlying infrastructure is boned, then so are you. Does your ISP have any form of security compliance? Have they been through SOCA, PCI, HIPAA? You know, are they secure? Or are you just putting your data in somewhere where you can be owned? Like iCloud. Side channel attacks. Moving swiftly on. When you stick your stuff in a virtual machine environment, you have to worry about everyone else that's on that hypervisor. You go to a cloud host, you have your virtual machine, but you also have any number of other people's virtual machines that may be on the same hypervisor as your data at that given moment in time. KVM, for instance, has kernel same pages to try and save memory, where it merges the same pages together. Unfortunately, timing attacks have shown us how to recover the data from other virtual machines, including, say, the SSL private keys. You've got to worry about phishing and spear phishing. This has got to do more with your staff and their perception of things. They haven't won a Ferrari. Okay? No, they haven't. They haven't won some holiday off to Hawaii. Instill it with these guys that filling in their bank information to receive £10 million from the King of Africa is not going to get them anywhere. Social engineering. I would highly recommend checking out a guy on YouTube called Apollo Robbins. He did a DEF CON talk called The Gentleman Thief. And in this, he will take your watch, your wallet, your phone, and your belt, and you won't even know he's gone. He's a pickpocket, but he's also a great entertainer. Basically, it's just the art of the con. The most famous example was Victor Lustig, who in the 1800s decided he was going to sell the Eiffel Tower for scrap. Not once, not twice, 3 times. On the 3rd time, he got caught. But on the way to the police station after he'd been arrested, he convinced the officers to let him go. Social engineering at its best, ladies and gentlemen. Unintentional omissions. No, I don't mean what happens after you've had a Mexican. What I mean is you have frequencies on all of your laptops and all of your gear. You have your FSB, your frontside bus of your CPU. You have the frequency of your RAM. You have the frequency of your display, your LCD, your CRTs, etc. Again, there was a lady called Melissa Elliott. She gave a great talk on this where you could use software-defined radio to intercept these signals and read the data out of them. The NSA has been doing this for years where they can reconstruct what you have on your display. So again, broken, but basically what this is supposed to see is, you see this huge lock, you turn it sideways and all of a sudden this bolt opens, you can get through the gate. So what I'm trying to get at is, because we love acronyms in this industry, access control lists. If you have an improperly configured access control list on your firewall or even on your building, you are going to get owned. Allow any on star, bad idea. POLP, that's not a typo of plop, I promise. It's path of least privilege. Basically the mantra of, if you don't need it, you don't get it. Not I want root because I want root. Provide a reason for it. We've got MAC and DAC, mandatory access controls and discretionary access controls. They can be summed up as discretionary access controls being your POSIX permissions, so these are your file permissions. There is no reason to 7.7 anything ever, okay? Mandatory access controls, SE Linux and AppArmor. These are the things that stop you from being owned once you've 7.7'd all the things. 7.7'd all the things. We've got a web application firewall. This is a specific type of firewall that looks at layer 7 attacks of your application and tries to block SQL injection, buffer overflows, and various other things. That's all the fun. We have IDS and IPS. Now, one of the things I get in conversation is a lot of people don't know what the difference between IDS and IPS is. So I summed it up in a couple of nice images. An IDS will tell you your house is on fire, but it won't do anything about it. An IPS, then, being an intrusion prevention system, should stop it, right? Well, that gets a bit funny too. It can do really, really weird things. If you've improperly configured it, it will attack things and probably not what you wanted to do in the first place. So let's move swiftly on to talking about an attack surface. So what is an attack surface? Areas in which your application, your organization, or anything about your person can be attacked. So I'd like you to guess who's got the biggest attack surface in this scenario of 3 people playing paintball. Here's a clue. It's the guy in the luminous pink vest with the bullseye on his chest. So we need to reduce the avenues of access or attack. Take the vest off. Reduce visibility. Seriously, he's in the woods. He's still got this pink vest on. Remove bad access control lists. Like I said, any bad. No, kill it with fire. Grant all. Your application does not need all permissions on your database. Path of least privilege, give it what it needs. It doesn't need super. If your application has super, I will give you an example after the talk if you want to talk about it, of where I inject a UDF and take over the database server. Bad file permissions will own you every time. 777, bad. 0640 the files, 0750 the DIRs. I know these aren't your standard ones, but please, 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 restrict them. So let's continue to talk about attack surfaces. It doesn't have to be limited to your database or your web application. Your attack surface is also your employees. If somebody knows that the HR of your business or somebody handling your contracts always stops off at Starbucks on the Monday morning to respond to their emails, they're going to hit them over the head and steal their laptop. So get them to encrypt said laptop and get into the habit of locking the thing, or walk around with it handcuffed to the hand. Remove redundant packages. I hate to say it, guys, Bluetooth D does not need to be on your rack mount servers. You wouldn't believe how many times I see this. You don't need cups on your prints on your servers either. You don't need, I hope you wouldn't be using Samba on your Linux servers, guys. I refer to you to the fact that it actually got owned again last week. Isolate the DB system, so basically put an access control list. Your MySQL server does not need to be able to query google.com. I have seen this. I have exploited this. It's bad. Don't be the guy running around the forest in the bright pink vest saying, hey, I'm over here. Come and own me. So let's talk a little bit about MySQL security features. Now, we'll talk about 5.6 and 5.7 briefly. In 5.6, you've got the plugin, nice one, SHA-256 password. Now, the only thing this really does is it changes the default password algorithm it stores and uses SHA-256 instead. You've got a couple other plugins like AuthPam. Now, the reason I pick on these two is they're the most widely known authentication plugins. Because within MySQL, you've got proxy groups. And these are groups kind of like the access controls you have in a Linux system. They're a group whereby you can say they're a sysadmin, therefore they need access to all the databases. They're in HR, they only need access to the employee databases and tables, etc. But when you don't have to do it on an individual basis, you do it on a group basis, and then you grant the individual proxy on that group. It's kind of a roundabout way to try and do user ACLs within MySQL. In 5.7.7 and onward, they've removed the requirement to have an authentication plugin to do it. So you can go back to the MySQL native password and still have the proxy groups. If you want proxy groups right now and you don't want to, throw a non-GA release into your production, which I assume none of you would want to do, then you're going to need to use an authentication plugin such as AuthPAM, which a lot of people do. They have it backing onto LDAP, or SHA-256 password, which I highly recommend because I couldn't break it. I tried. So let's talk quickly about selective grants. Like I said, no all on star.star. In a previous talk, I called this guy the key maker. Okay? You got all on star.star. Oh, you've also got with grant privilege. If you do with grant privilege, and I've seen a lot of tutorials that say, please install our WordPress deploy, or please install our PHPMyAdmin with all the grant privileges and all the things. And then I don't even need your permissions or your password. I'll go and make my own. No super. The image is dropped off. I call super the trolling privilege. The reason I call super the trolling privilege is if I wanted to do nothing else, I can sit there killing all of your queries. Just do whatever I want. I could reset your slave. I could reset your master. Fun times. So, yeah, a little bit of textbook stuff. Here's the differences you have to be aware of. The MySQL authentication handshake is actually a hell of a lot more secure than the storage of the password in the first place. The default storage MySQL native password is a double pass of SHA-1 of the password. Hands up if anybody knows why this is a bad thing. If anybody knows what Google have recently said about SHA-1 and the fact that you need to deprecate it because it's been exploited. So your authentication handshake is a little bit different. If you ever run Wireshark against a plain text of MySQL, you'll see this. You will send a query, you'll get the capabilities of the server, and the server will send back a payload that says, hi, I'm the server, here's my capabilities, and here's the salt to use for the connection. It will then, your client will respond with this, which is a SHA-1 of the password, XORed against the salt, plus the same storage of the local password. So you get this awful, awful string, and the reason why this is much better is it's computationally much more of a pain to calculate than this. And that's the biggest mantra about your systems. Make it difficult for the attackers to get in. 99% of them will get bored and go away. Strong passwords are key. Now this is where my video fell over, so I'm going to have to pop it up here. I got a really good set of passwords here that I recovered. These are stored in the MySQL users table, and it took a grand total of 1.387 seconds to crack them. I call them cracking them because the media love to say it, because I cracked the password. No, I didn't. All I've basically done is run a dictionary against the hashes, run a dictionary against the same algorithm, which is a double SHA-1 pass of the words, got the resulting hash and said, is this the same? Oh, looks like it is. Ah, great. Thank you very much, LibreOffice. Okay, here we go. So, secure password. Nope. That's pretty much what you're getting at. You have to have strong passwords. Even though it's hashed, please, please, please make sure you remember strong passwords are still important. These are the passwords we actually recovered. They were much past, such bad, wow. So let's talk about require SSL. What would have stopped me from getting some of these hashes in the first place would have been if the communication was actually encrypted in the first place. Put SSL on all the things. They're making it default in 5.7. That's at least what some of the guys in Oracle are telling me. Make sure this makes the authentication actually take place over SSL. So you will see the salt and the capabilities come back, but that's all you'll see on the wire. You will never see the resulting SSH1 pass of the password, XORed against the salt, concat, blah, 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 blah. You won't see that. You'll see all the nice SSL stuff. Makes it a little bit more difficult. There is a good amount of overhead, and I've linked here, there's a blog post. If you have connection pooling, you will want to use it. That removes 90% of the overhead because it's all in actually trying to establish a connection in the first place. You can change the SSL cipher. Don't rely on the defaults. Some of them are in there for backward compatibility. Some of them use the MD5 hash, which hopefully I don't have to tell you is bad. Let's talk about training your employees. So up here, from the way I see it, you can either run from it or learn from it. Don't do this. Don't say, I'm too small a business, no one will ever want to hack me. No one, that's okay, I'm a nice person. I've never said a crossword to anyone. You're the best targets. You won't tell anyone you've been hacked. We love you. So train your employees. It's not as difficult as it might sound. You don't have to send them a seminar and they come back and go, I'm never using a computer again. It's really easy. Don't open an email that says free things. That's probably one of the best things you can tell them. But I want free stuff. Look, if I open this program, I see naked pictures of celebrities. Nope, stop. Train yourself. The reason you should train yourself is, how do you expect others to follow you if you can't do it yourself? Don't do the head in the sand, and just be aware of potential threats. Simplest one I can think of is somebody offering you to drive you home with your own car. Just give me your keys. Please? No takers? So let's talk about more acronyms. BYOD. Anybody have any idea what BYOD is? It's a short acronym for bring your own device. How many people's employees bring their own phone to work and use email on it and might use VPN on it and SSH? Give me your phone. I want your infrastructure. I think we're getting to the point now. IoT, anyone? Internet of Things, very popular subject right now. You don't need Wi-Fi in your light bulb. How many times can I say this? Just because it's cool doesn't make it good. There is a proof of concept out there that takes the Philips RGB light bulb and turns it into something that sniffs your Wi-Fi connections. Let's talk about malicious human interface devices. In fact, did I bring my bag over here? No, it's over there. And abusing and / malicious Wi-Fi. And I'm sorry, I've got to run over here. The TLDR of this is there are so many things you can do, and some of you may have seen me running around with a bag of toys. I'm not going to go through the malicious Wi-Fi because we are actually running out of time. If you want to see that, come and see me after. I have a nice little device that rickrolls you every time you try to access a site, and also plays Polka Dot Circus from Madagascar. So, we have fun with all these things, which I can't find now. Here we go. This is an oversized example of a malicious human interface device. It's oversized because it makes a point. You can see it. I've seen these embedded in mice. I've seen these embedded in keyboards. I've seen these embedded in free USB drives you might pick up from a conference. Okay. So this one should be really easy. I've slowed this down, and I've slowed this down so you can actually see it. This thing will write key presses in less than a millisecond. However, I've slowed it down. I think there's about 20 milliseconds gap between each one. Oh, look, it types. So the TLDR of this really is, if I can make it be a keyboard, what else can I make it do? Who uses keyboard shortcuts to open their favorite programs? No? Well, there's a lot there. You can open a terminal. What happens when I open your terminal? I can run anything I want as your user, such as, say, a bash reverse shell back to my command and control server. It's all right. You can hibernate your laptop. When you connect, it'll be there again. The best example of this and the most simple, who has an organization where they have a timeout policy for screens? Yep, most people. Shall I program it to be a mouse that wiggles every few seconds? Uh-oh, it's not going to time out anymore. So that 60-second policy to lock me out of the machine once it's timed out, doesn't matter. I plug this little device in, and these are great. These are little microcontrollers. I can put a photo sensor on there so that it can detect when you're sat in front of it and when you're not. There's lots of things. Iron Geek gave a great presentation where he embedded it in a mouse, and he discussed all of these concepts where he could tell when your hand was on the mouse that it was embedded in and took it off. He could tell, gave it the instructions as to when to change between a mouse and an exploit payload with a micro SSD in it and actually start pulling all the data off. This thing will open in less than 10 milliseconds. It will open a terminal. It will send the malicious payload, connect to the command and control server, and completely and utterly own your infrastructure. And that's the wrong talk. Okay. So that was supposed to say show me, and that's kind of what I'm getting at here. I've just been given the 5 minutes card. So if you want to speak about any of the Wi-Fi or any of the fun toys I've got with me, please come and see me later. There's a huge bag of them. And any questions? Or have I scared you all into silence? Okay, cheers, guys.